Welcome to a session on determination of rigidity modulus of the wire by using the torsional pendulum. Let us see what are the apparatus required in this experiment. This is the L-shaped clamp which is mounted to the wall, and this is a wire, steel wire, and this is a brass disc. Just these are the apparatus, and apart from this we have screw gauge, we have vernier calipers, and we required a scale, meter scale, and apart from that you required a timer. So these are the apparatus required for this experiment. First let us see what is the formula to find out the rigidity modulus of this experiment by using. You can find out rigidity modulus which is denoted with eta as 8 pi by 2 into mr square by a to the power of 4 into L by T square. Here you see students, 8 is constant, pi is constant, its value is 3.14, 2 is also constant. Here m is the mass of the disc, and here r is the radius of the disc, and here a is the radius of the wire, and L by T square we can find out from the graph. First let me explain what is m, r, a once again. Here this is the brass disc, here capital M is the mass of this disc mass we evaluated, and it is 1000 grams, and here A is the radius of this wire radius is A, and here R is the radius of this disc, here it is the diameter divided by 2 is equal to radius. First let us calculate how to find out the radius of the disc. For this we require vernier calipers. This instrument is called as vernier caliper, students. With the help of this one we are able to calculate the radius of the disc. If you clearly observe the vernier calipers, it basically consists of two scales. This scale is called as main scale, and here you can find this scale is called as vernier scale. So the formula for the least count is 1 MSD divided by number of vernier divisions. So the denominator is very clear, students. Here you can find only 10 lines. So 0th line, 5th line, and 10th line. So the denominator number of divisions is 10. So what is MSD? What is one main scale division value? Here if you observe, this is the centimeter scale. Okay, 0th centimeter, 1 centimeter, 2. Okay, if you take any two successive readings, 0 or 1 or 2, so the difference between 1 and 0 is 1 centimeter. 1 centimeter is nothing but 10 mm. This 10 mm is divided by 10 lines, which means 10 divided by 10 is equal to 1 mm. Here you can see, students, 1 centimeter is divided by 10 lines. Okay, 1 centimeter is nothing but 10 mm divided by 10. So obviously it is 1 mm. So 1 main scale division is equal to 1 mm. The least count of this apparatus, as I told you, that 1 main scale division is nothing but 1 mm divided by number of vernier divisions are 10. So 1 by 10 is equal to what, students? 0.1 mm. If you convert it into centimeters, it is 0.01 centimeters. So how to measure the radius of the disc? So we have to measure the radius of the disc by using the vernier calipers. I already introduced you, this is the vernier calipers. Place these two jaws here like this. Insert this brass disc in between the two jaws of the brass disc along the diameter. Okay, so now you see, if you clearly observe the tabular form, we have MSR. What is MSR, students? So 0th line on the vernier is coinciding with 12.1. So MSR is what? 12.1. Here you observe 0th line on the vernier scale is in between 12.1 and 12.2. So we will take the lower value, so 12.1. So the vernier coincidence, out of the 10 line, out of the 10 lines in the vernier scale, one of the line exactly coincides on the main scale. Here you observe this line. What is this line? 5th line. 5th line is exactly coinciding with this line, so it forms a straight line. No other line forms the straight line pattern. So this 5th line exactly coincides with this line on the main scale. So vernier coincidence is 5. Right. Now take the second reading for more accuracy. Let us select a different place. Now I inserted this brass disc in between the two jaws at a different position when compared to previous case. Now let us note down MSR. Here the 0th line on the vernier scale is coinciding with 12.1 on the MSR. So MSR is nothing but 12.1. Here this time the vernier coincidence this time may be changed. Yes, here it is. Yes, this time also we have 5. This 5th line coinciding exactly with this line and form a straight line. Okay, so vernier coincidence is 5. Now let us calculate this. What is this? VC into LC is denoted with what? B. So here VC is 5 into LC. The least count of this apparator, as I told you, that 1 mm main scale division is nothing but 1 mm divided by number of vernier divisions are 10. So 1 by 10 is equal to what, students? 0.1 mm. If you convert it into centimeters, it is 0.01 centimeters. So 0.01 centimeters. Obviously you would get 0.05 centimeters. Here also the same thing. VC, vernier coincidence, is 5 and least count is 0.01 centimeters. Obviously it is 0.05 centimeters. Now what is the final thing? Radius is equal to A plus B. So radius, what is A, students? Here 12.1 plus VC into LC. So this VC into LC is nothing but 0.05. Okay, here also 12.1 plus VC into LC is 0.05. Here the value becomes 12.1 plus 0.05 is equals to 12.15. So the same thing here also, because upper value and lower value is same, 12.15 centimeter. Actually what we got is diameter of the disc. Diameter of the disc is equal to 12.15 centimeters. So dia by 2 will give what, students? Radius. Okay, so here 12.15 divided by 2 is equal to 6.075 centimeters. This is the radius of the disc. This is the diameter. Okay, diameter by 2. This is called as what? Radius. So here 12.15 centimeters is nothing but the diameter of the disc. By 2 will use what? Radius. So we determined the radius of the disc as 6.075 centimeters in this experiment. Now another task in this experiment is measurement of the radius of the wire. Here this is the steel wire and this steel wire radius is A. Yes. How to measure the radius of the wire? With the help of this apparatus. This apparatus is called as a screw gauge. Basically this screw gauge consists of two scales. This rotating scale is called as head scale, and there is another scale. Here you can observe this scale is called as a pitch scale. Generally this screw gauge may have errors. Let us see what type of errors it is having. Here you can see, students, this line on the pitch scale is called as index line. If the index line exactly coincides with the 0 on the head scale, then it is no error. This is called as no zero error. And let us say there are two cases. Generally if this device become older and older, it may have either positive error or negative error. Sometimes what happens is the 0 on the head scale will go below the index line on the pitch scale. So this line is index line which is located on the pitch scale, and here 0 on the head scale exactly not coinciding with this 0. So this 0 on the head scale is below the 0 on the index line. This type of error is called as a positive error. Sometimes what happens is this 0 on the head scale may go above the 0 on the index line. So this is the index line and this is the 0 on the head scale. So this type of error is called as a negative error. Let us see our device having what type of error. If you clearly observe, this line is called as index line. This line is called, this horizontal line is called as index line. Index line, and let us rotate the head scale, whether it is exactly coinciding with the 0 on the head scale or not. So if you clearly observe, the index line on the pitch scale not exactly coinciding with the head scale 0. So just it is 2 lines below the index line, so which means that it is having positive error. What is the amount of positive error? +2, because this head scale is 2 lines below the index line, so the error is +2, the correction is -2. Yes, before going to measure the radius of the wire, let us calculate the least count of the apparatus, this screw gauge. So the formula for the least count is pitch divided by number of head scale divisions. Okay, I will explain what is pitch later. First find out denominator, number of head scale divisions. Here you observe, students, this is the 0th line on the head scale. Okay, 10 lines, 20 lines, 30. Okay, so if you come back 90 plus 10 is equal to what? 100. So total number of head scale divisions are 100. So the denominator is number of head scale divisions are 100. Now let me explain what is pitch. Pitch is equal to distance moved by number of rotations. Here you can see, students, this is the index line on the pitch scale and this is 0. If you clearly observe, this 0 on the head scale just below 2 lines from the index line. So what type of error it is? Positive error, and the error here is 0 error. The error is +2 and the correction is -2 error, because the head scale 0 just below 2 lines of the pitch scale, this is positive error. How many lines below? 2. So that's why error is +2, correction is -2. Now let me rotate it for one time. Let me complete one rotation. Yes, I completed one rotation. If one rotation completed by the head scale, the distance moved on the pitch scale is 1 mm. This is 0th line, this is the first line. So first line is nothing but 1 mm. Let me complete another rotation. Okay, so by completing 2 rotations, what distance moved by the head scale? So here it is 1 mm, this is the 2 mm. Okay, so now let me calculate the pitch. Distance moved is 2 mm. By rotating it for how many times? 2 times. Rotations are 2. So 2 by 2 is nothing but what? 1 mm. So here pitch is equal to 1 mm divided by number of head scale divisions is equal to 100. 1 by 100 is obviously 0.01 mm. If you want to convert it into centimeters, one more 0 will be added. So 0.001 centimeters. So in this experiment, let us take the LC, the least count in mm, finally convert it into centimeters. This is easy. Okay, here to note down the values, first we have serial number like 1 2. Here we have to note down the pitch scale reading and the head scale reading. How to note down the pitch scale reading and the head scale reading? Let me explain. First, little bit move this jaw in opposite direction to insert the wire in between the 2 jaws. So let us make 1 or 2 ticks. Later you can see how to note down the pitch scale reading and head scale reading. Here you can see, students, the below scale is pitch scale. This is 0th line, this is the first line. We are able to see clearly the first line on the pitch scale. Hence the pitch scale reading is 1, because we are able to see the first line on the pitch scale. So the PSR, pitch scale reading, is 1. So next we have to measure the head scale reading. What is head scale reading? This line is called as index line on the pitch scale. So what is the value in front of this index line? That is nothing but head scale reading. Here if you observe, head scale reading is, this is 0 and the above reading is 10. which means that this reading is 0, 1, 0, 1, 2, 3, 4. So fourth line on the head scale exactly coincide with this index line on the pitch scale. So HSR is 4. What is CHSR? CHSR is nothing but corrected head scale reading. We have correction of -2. We got error of positive error +2. So the correction is -2. So CHSR is 4 minus 2, that is equal to 2. Right. Next, note down the another reading. So here I am selecting another place on the wire. So previously I have taken in this region. Now I am going to take the reading in this region. Okay. Now let us make 1 or 2 ticks. First note down the pitch scale reading. So we are able to see 0th line as well as the first line, that is the first line on the pitch scale. So the pitch scale reading is 1 and the head scale reading is, you see. So what is the reading presented on the head scale in front of the index line? That is nothing but head scale reading. So this is the index line on the pitch scale. It exactly shows this is 85, 86, 87. 87 is the head scale reading. So you see clearly, students, at one place we got a PSR as 1. In both cases we got 1, but HSR reading is different, which means that that wire is not uniform. That's why we are taking the average value. Okay, here what is the corrected head scale reading? 87 minus 2, which is equals to 85. Next calculation is what? CHSR, corrected head scale reading into least count. So here in the first case CHSR is 2 into the least count of the apparatus in mm is 0.01, which is equals to CHSR into LC becomes 0.02. Similarly 85 into least count, which is 0.01, will gives you 0.85. Okay, here we got B. CHSR into LC is assumed as what? B. PSR is A. So finally diameter of the wire is A plus B. Here A is 1 plus B is 0.02. Here A is 1 plus B is 0.85. So 1 plus 0.02, obviously 1.02 in mm. This is 1.085 in mm. Let us take the average. So the average becomes 1.02 plus 1.08 divided by 2. That is 1.05 mm. Convert this into centimeters, students. Actually this average value is the diameter of the wire. This is the diameter of the wire. It is 1.05 mm. So what is radius, students? Obviously radius is equal to dia by 2, diameter divided by 2. So here 1.05 divided by 2 in mm. So 1.05 divided by 2 is equals to 0.525 mm. Convert this into centimeters, students. What should multiply? We should multiply 0.1. So obviously it becomes 0.052 in centimeters. So we determine the radius of wire. This is nothing but small a. So students, we determined the radius of the wire A as 0.052 centimeters. Next, how to evaluate L by T square? For this, let us start the experiment. This is the tabular form corresponding to this experiment, student. First one is serial number, which means like 1, 2, 3. So here length of the wire between the check nuts. Here let me introduce what is the length of the wire. Here you see students, this is the brass disc. So this is the brass disc and this is called as a check nut. Similarly, this L-shaped clamp which is mounted to the wall also having what? A check nut. So the length of the wire between these two check nuts is called as the L, length of the wire. So I already set it for 50 centimeters. If you clearly observe, you would get it as 50 centimeters on the scale. So this is, so the length of the wire between the two check nuts is called as what? L, right. So the next, time taken for 20 oscillations, trial 1, trial 2. Okay, we will do the experiment for 2 times, for one time trial 1, for another time trial 2. I will explain the process how to calculate the time taken for 20 oscillations, and the average of trial 1 and trial 2 is nothing but this average. So time period, time taken for one oscillation. Actually we are able to get time taken for 20 oscillations, but I need time taken for one oscillation. This is the average divided by 20, and later this average divided by 20 is time period. It is indicated with t and t square of this t, and L by t square. L is nothing but length, L by t square. Let me start the experiment first. So in this experiment what we are going to do is, we have to find out the rigidity modulus of the wire. So what is rigidity modulus? It is the ratio of shear stress by shear strain. So what is shear stress, what is shear strain? Here you observe, this is the force I am applying on the wall. This is what force? Normal force. So this is the direction of the wall and I am applying in perpendicular direction. This is the normal force. Okay, the force applied per unit area is called as what? Stress. Okay, that is normal stress. But here we are going to apply shear stress, which means that you take this and we are applying the force in the perpendicular direction. This becomes the normal force application. But here I am applying shear stress, which means that I am applying in this direction parallel to the axis of this rubber. So you are able to see this rubber is getting deformed. Okay, this is called as a strain. So the ratio of shear stress applied to the strain produced, shear strain produced, is called as what? Rigidity modulus of the wire. So here I am applying the force in this direction. Okay, so that this wire is little bit deformed, that will create application of stress, will create little bit strain. So the ratio between shear stress to shear strain is called as what? Rigidity modulus. So let us start the experiment first. Here length already I set it for 50 centimeters. Now let us calculate time taken for 20 oscillations. For this we need a stop clock. Here this is start, 1 second, 2 seconds, like that. So the same one is stop and this is reset. Okay. So to calculate the time taken for 20 oscillations, let us take a reference point. Okay. So in equilibrium, this is the central point. Let us consider that this is the equilibrium. So this is the point of consideration or equilibrium position. So now what I am doing is, I am twisting the wire above the axis. Okay, with small angle, so that what will be developed inside the wire? A torque will be developed inside the wire. So it tend to oscillate. These oscillations are simple harmonic oscillations. So during this period we have to find out the time taken for 20 oscillations. So first of all, what is one oscillation? For example, if you clearly observe, this chalk piece mark is going from left extreme to right extreme. Okay, then what is one oscillation? Left extreme, right extreme, left extreme. This becomes one oscillation. In this way you calculate time taken for 20 oscillations. Let me start once again. Let us start both the process at the simultaneously. One oscillation, 2 oscillations, 3 oscillations, 4 oscillations, 5 oscillations, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Just so in trial 1 the time taken for 20 oscillations is 52 seconds, student. Similarly you have to note down the time taken for 20 oscillations for another time, that becomes trial 2. Let us do it once again. So reset it. Now you can see zeros. Okay, so now I twisted this brass disc from equilibrium position and I starting both simultaneously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time for 20 oscillations the time taken is 51 seconds. So the average becomes 52 plus 51 divided by 2, which is 51.5. So this is the time taken for 20 oscillations. Similarly you calculate time taken for 20 oscillations for 60 centimeters of the length of the wire and 70 centimeters. How to set it? Let us see. Now this is 50 centimeters, right? Just lose the upper check nut. So now let us evaluate what is the distance. So just lose the upper check nut. So now let us evaluate what is the distance. Here you see, students, the length of the wire is 60 centimeters. 60 centimeters. Now reset the stop clock. So twist the one oscillation, 2 oscillations, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time the time taken for 20 oscillations is 57 seconds. So let us take the trial 2 also. Reset the stop clock and this is the mean position. Twist the wire for some angle and start both simultaneously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time the time taken for 20 oscillations is 56 seconds. Take the average of these two, it obviously 56.5. So finally, this is the last reading, students. Adjust the length between the chuck nuts 70 centimeters. Here you can clearly see. So the length between the two chuck nuts is 70 centimeters. Yes, every time you have to locate a equilibrium position. So this time I am going to take this as the equilibrium position. So now calculate time taken for 20 oscillations. Let us twist this brass disc about the axis for some angle and let us release both simultaneously. Let us start this stop clock and release the brass disc simultaneously. One oscillation, two oscillations, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see the time taken for 20 oscillations in this case is 60 plus 1, 61 seconds. 61 seconds. Now reset this and make trial 2 with the same length. So the length between the two chuck nuts is 70 centimeters. I am doing the trial 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this time we got the same time, 1 minute 1 second, which means 61 seconds. Okay, so the average is also 61 seconds. In this way we got Time taken for 20 oscillations for 50 centimeters of the length, 60 centimeters of the length, 70 centimeters of the length. Now calculate 51. Here you have 51.5. What is this 51.5? It is the time taken for 20 oscillations. Now calculate time taken for one oscillation. 51.5 divided by 20. So make t square, which means 2.56 into 2.56, which will give the t square value. It is 6.55, and 2.82 into 2.82 will gives the t square for 60 centimeters. For 70 centimeters, the t square value is 3.05 into 3.05, which will give us 9.30. So finally what we have to do is calculate the L by t square value. Here you know students, L for first reading L value is 50 centimeters, t square is 6.55. So calculate L by t square value. It is 50 divided by L value is 50 and t square value is 6.55. So it is 7.63. Similarly, calculate L by t square for 60 centimeters. L value is 60 divided by t square value is 7.95, which will give us 7.54. And finally, L by t square for 70 centimeters is 70 divided by t square value is 9.30, which will give us the value of 7.52. So these are the L by t square. Take the average of all these. 7.63 plus 7.54 plus 7.52 is equals to divided by 3. So divided by 3 will give 7. The average value of L by t square is 7.56. So this is the theoretical L by t square, students. If we go back in the formula, so how to find out the rigidity modulus? Eta is equal to 8 is constant, pi is constant, 2 is constant. We know m value 1000 grams. R we calculated, A we calculated, L by t square we require. Actually you calculated L by t square here. This is the theoretical L by t square. 7.56 is the theoretical L by t square. What you have to draw in reality is, so take L length along the x-axis in a graph sheet, take t square along the y-axis in a graph sheet and draw the graph between L and t square. So select any point. Here we selected this point and extend a line from that point to x-axis, extend a line from that point to y-axis. So the extension of this line onto the x-axis will give t square value, this will give t square value, and the extension of line to the y-axis will give L value. So calculate L by t square. The formula is 8 pi 3.14 divided by 2 into m. Here m is the mass of the disc. We calculated with the help of a weight balance. We determined it as 1000 grams, and r square is nothing but, here what is r, students? 6.075 centimeters. 6.075 whole square divided by 8 to the power of 4. Here what is A? A is the radius of the wire. Here it is 0.052 centimeters. 0.052 centimeters whole to the power of 4 divided by L by t square. As I already told you, this is the L by t square, students. Actually you have to draw the graph between L and t square, then from that you have to evaluate L by t square value. But here this is the theoretical L by t square value. We got 7.56, but you have to take it from graph. Okay, so for experimental purpose, for the demonstration purpose, I am taking the same theoretical value. So the L by t square value is 7.56. Let us simplify. Yes, by simplifying this, you would get 0.479 into 10 to the power of 12 dynes per centimeter square. So simply what I substituted is 8 by 3.14. 2 mass of the disc is 1000 grams and radius of the disc we calculated it as 6.075 whole square divided by A. What is the radius of the wire? 0.052 whole to the power of 4 into L by T square is 7.56. Actually, you have to evaluate it from graph. Okay, so by simplifying this, you would get 0.479 into 10 to the power of 12 dynes per centimeter square. So this is the rigidity modulus of the wire.